Synchronization is a very important concept in the context of multi-threading. When two or more threads are trying to access the same method at the same time, it could run into trouble. It could cause data corruption. We will see how data corruption takes place and what we can do to fix this issue, how we can ensure data corruption doesn't take place. And Java being a language for multi-threading, it's called multi-threaded language, means it supports multi-threading as part of the language. So our life is much simpler and it made our life easy. We can easily implement the solution to this problem. Well, I'll explain the term synchronization once we understand the problem. Well, this is without synchronization. Two threads are trying to enter into the same method at the same time. So thread 1 entered into method M1 at 10:10:10, and before it completed, thread 2 also entered into the same method. Like this, when two threads enter into the same method at the same time, this could cause issues. So what kind of issue it can cause? We will see. Now this is with synchronization. When you apply synchronization, you do not allow second thread to enter into M1 as long as first thread is still inside M1. So you are saying one at a time. Either thread 1 can enter into it or thread 2 can enter into it, not both. Now, why we do not allow second thread to enter into method M1? To understand it, we need to understand something slightly different. To start with, thread 1 is invoking push method of our stack class, assuming S is an object of a stack. Push is a method and we want to push 10 from thread 1. And this is done sometime 10:10:10. Now, thread 1 entered into push. It is supposed to take 2 steps to complete the task. It should place the value at the top of the stack. Top is 0 in the beginning. The data, which is an array of 10 integers, even that is having all zeros, because arrays are initialized in Java, so all elements are initially zeros. Now it should place the value at the top, so 10 should be placed here, and it should increment the top by 1 so that it becomes 1, and next element will go into first position. But that's not quite happening. Instead, the first thread is executing the first statement and then it is losing control. What if thread 1 is losing control after the first statement is executed? As you know, threads can lose control anytime and another thread might be given control. So if thread 1 lost control at this point, that means only the value is placed and the top is not at incremented. At this position, at this juncture, thread 1 lost control and now control is given to thread 2. So thread 2 is getting control and thread 2 knows nothing about what happened with thread 1, and thread 2 is silently entering into push method. And the most important point is both thread 1 and thread 2 are using the same stack object. It is only one object. the same object is being accessed by two different threads. That's the scenario. I will show you how we can simulate this later with a slightly different example. But the point to be noted is both these threads are accessing the same object. The object is referred using S. Now thread 2 is trying to push 20 and it doesn't know anything about what's happening with thread 1. So when it says push 20, it enters into it. But if you remember the scenario, thread 1 already entered into push, did not complete the task, it lost control after the first statement, and now thread 2 is entering and it proceeds and it places V, which is 20 at top, but the top is still 0. When it enters, it was still 0 because top was not incremented by previous thread. So top is still 0 and at that position V is placed, so 20 is placed. And then it will proceed further. It is going to proceed further and increment top by 1. So by the time we are here, 0th element is having 20. So that is data corruption. It was supposed to be 10 and 20 should be here. But we placed 20 on the top of 10. It's because the previous thread did not increment top. It did not increment top because it lost control of it. And thread 2 entered into that without knowing about all that. It just placed V at top and that itself is resulting in data corruption. Now thread 2 continues, we assume so, okay. If thread 2 also is losing control, it's a different story. But you never know, this can happen. If this happens, after overwriting it, it will proceed further and it is incrementing it by 1. And subsequently, thread 1 will regain control and it is going to then continue from where it left. So thread 1 will resume and it is going to increment the top by 1, but it's too little too late because by the time it incremented top, the damage was already done. The damage was already done means thread 2 already entered into push. Thread 2 overwrote the value in 0th position and then it went on to increment top. Incrementing top was not the issue. Overwriting value at 0th position was the issue. It happened because we did not complete the task in thread 1. So if you see how we can fix this problem, you should not allow thread 2 to enter into push until thread 1 completes the task. So I repeat, you should not allow thread 2 to enter into push method until thread 1 comes out of push. Because if thread 1 comes out of push by incrementing top, then there is no problem. All is well. But we are entering into push method from thread 2 before thread 1 could complete the task. That caused this data corruption. And another very tricky part here is you might not come across this scenario for weeks and even months, but on one bad day you might run into this scenario and your data is corrupted. Because it is not something that is going to happen very consistently. It might not happen for quite some time, but all of a sudden it might happen. So there were cases where people used multiple threads and ran into very difficult to detect bugs. and they detected bugs eventually and understood the bug was because of multiple threads. So multiple threads can cause this kind of tricky situations. You have to be aware of it. So we understood if thread 2 is allowed to enter into push before thread 1 comes out of push, it could cause this kind of damage. Now, is it okay if you allow thread 2 to enter into pop when thread 1 is still in push? We are trying to understand a different scenario. What if thread 1 is in push, last control there, and what if I enter into pop instead of push? Will that be fine? Because pop is a different method. Well, the answer is no, a big no. It's because both push and pop are using the same data. The problem is with the data. We are talking about data corruption. Even pop is using the same top and same data. So if you allow thread 2 to enter into pop, even that can cause some incorrect results. So the requirement now is little broader. When thread 1 enters into push, do not allow any other thread to enter into either push or pop. So I repeat, when thread 1 is in push, do not allow any other thread to enter into push or pop because both these methods are sensitive. You might allow some other methods but not these two because both of them are sensitive and manipulating the data. Well, you as a programmer should understand which methods are sensitive, which are not. Okay, now we understood the requirement. The requirement is when thread 1 is inside push method until it comes out, until it completes push method, do not allow thread 2 or any other thread to enter into push as well as pop. It may not be just push and pop, it might be a lot more methods which are considered to be sensitive. Okay, so once you understand what is to be done, now it's time to do it. This is how we do it. The best part of it is you just need to know what is to be done, and doing it is so simple. Just give synchronized keyword. Once you give synchronized keyword, you achieve it. And synchronized keyword is not just for this. You have to synchronize even pop method. Both the methods are synchronized. What it means? Here we are. Once you make a method synchronized, you are asking for synchronization. Synchronization means one at a time. Only one thread can enter into it at a time, and until it comes out of it, no other thread can enter into it. But that is not implemented by any code written by us. Instead, it is implemented with this keyword. That's it. That's wonderful. Now, how Java is internally implementing synchronization? Here we are. When a method is synchronized in a class, every object of the class, this is the object, every object of the class is associated with what is called as monitor. There is a component called monitor, and that is the term Java uses. The monitor is ensuring only one thread can enter into any synchronized method. How? When thread 1 wants to enter into push method, again let's assume 10 10 10 some time point. When thread 1 is trying to enter into push method at 10 10 10, Java is going to check whether monitor is empty, the monitor associated with the object. If monitor is empty, then the thread will be put in the monitor. The monitor is now associated with thread 1. Only after a thread enters into monitor, it can enter into push method. So to enter into any synchronized method, the thread should first enter into monitor, and then it will be allowed to enter into the actual method. That's the concept. Only when it can enter into monitor, it is allowed to enter into synchronized method. Done. Now thread 1 entered into it. First statement is done, and again as usual it lost control. Now as thread 1 lost control, control is given to thread 2. Just like the previous scenario. Now thread 2 is trying to enter into push method. Again, thread 2 is unaware of developments in thread 1. Innocently, thread 2 is trying to enter into push. But thread 2 cannot enter into push because thread 2 is invoking synchronized method. A synchronized method is the one that cannot be invoked unless the thread enters into monitor. But now monitor is not empty. Monitor is associated with thread 1. Until thread 1 leaves the monitor, no other thread can enter into this. So when thread 2 wants to enter into push or even pop, both are synchronized. So the rules are same. Even if I try to enter into pop, access is denied because it cannot first enter into monitor. So simple. It's all handled by JVM. It's none of your business. JVM takes care of creating monitor, taking the thread into monitor before it allows that to call synchronized method. So thread 2 cannot enter into push or pop because the monitor is occupied, it's not empty. So thread 2 is waiting. When does it get the chance to enter into push or pop? When thread 1 exits that. When thread 1, after receiving control, completes the task and exits this push method, it is leaving the monitor. When thread 1 leaves the monitor, then if thread 2 is calling the method, it will proceed. So thread 2 is right now waiting, and it cannot enter into push until thread 1 exits monitor. So that is the concept of synchronization. If you mark a method as synchronized, Java takes care of implementing synchronization for you through the concept called monitor. So no thread can enter into synchronized method when another thread is already present. So the term synchronized or synchronization means one by one after another. Okay, asynchronous means all at the same time. Synchronous means one by one. So this is the method, or these are the methods where only one thread is allowed to enter. So that's the concept, and it's a pretty important concept. If you are planning to use multi-threading, you must make sure you are using synchronization. If you don't use synchronization for sensitive methods and still entertaining multiple threads, you're asking for trouble. Because sooner or later your data will be corrupted and it is going to be very difficult to detect and debug. So make sure you understand the importance of synchronization in the context of multi-threading. So you have two simple options. Either use single thread and do not entertain multiple threads, or create multiple threads and make sure sensitive methods are synchronized. But there is one more option interesting. If your objects are immutable, means if objects are not at all changing, if there is no change of data, then there is no need for synchronization. We don't need to worry about multiple threads and synchronization when objects are immutable. So you don't worry about synchronization for strings because strings are immutable. You don't worry about synchronization for local date because even those are immutable objects. They cannot be changed. But if you are talking about string buffer, which is a mutable object, you must implement synchronization. In fact, string buffer is synchronized. So you cannot modify string buffer from two threads at the same time because it is internally synchronized. You can see that in the documentation clearly. You get a message saying it is synchronized and thread safe. When somebody says that a particular class is thread safe, it means its objects can be used by multiple threads without any concern because it is taking care of synchronization. So that is the concept of synchronization, and hope you got some idea about what it is. Now, let me show you how we can implement this. I show you program where we don't use synchronization in the beginning, and we then allow two threads to enter into the method. But once you turn on synchronization, then only one thread can enter into method, and until it comes out, the other thread cannot enter. So you can see a drastic difference between synchronized version and non-synchronized version. Let us see the code. Here we are. I'm talking about a class, and here we are talking about print method. It's not doing anything that fancy or complex. It just prints numbers. It is printing numbers 1 to 5, and after printing the number, it is sleeping for a while. Intentionally, I try to put current thread to sleep. And whenever I put a thread to sleep, you know, control switches to other thread. And as a result, you get the other thread invoking this method. So let us see how this happens. Now the data class is being used by our thread. This is our thread. We provide the data object and we call print method from run. So the thread is going to invoke print method. Now we create two threads. Both the threads are associated with the same data object. Now this is how we simulate. Two different threads are associated with the same data object. Now both the threads are starting. So thread 1 starts. You know, when you start a thread, you enter into run method. And when you enter into run method, you are going to call print, and this print is called. So we enter into this loop. After printing number 1, it is put to sleep. And then control is given to second thread. And if second thread is then entering into print method, it is going to print again number 1, and even it is put to sleep. So thread 1 prints a number, sleeps. thread 2 prints a number sleep, but the point is both the threads are able to enter into print method. Let's go run this. And you can see the output like this. You're going to get numbers from both the threads, and you see 1 1 2 2 3 3 4 4 5 5. That's expected because thread 1 enters into it, prints 1 and sleeps. Thread 2 is also entering into the same method and printing 1 and sleeps. In the meantime, thread 1 will wake up. But if I make this synchronized, if I make it synchronized, just one keyword. Once you put that synchronized, immediately synchronization is implemented. Now, can you guess the output if it is run now? Because we synchronized print. If thread 1 enters into it, thread 2 cannot enter into it until thread 1 exits. Whether thread 1 is sleeping or doing something else, it doesn't matter. Only after thread 1 comes out, thread 2 can enter into print. That's the concept of synchronization. So if I run this program now, the output is going to be quite different from this. It's not going to be this. Then what is it going to be? Well, this is the output. So you're going to see 1, 2, 3, 4, 5, because when thread 1 enters into it, it is going to print 1 and then it is sleeping. But thread 1 entered into a synchronized method, and until it exits, thread 2 cannot enter. So thread 2 is simply waiting. Here is thread 2. Thread 1 is then coming out of the sleep after 100 milliseconds, and it will print 2, then 3, and so it completes the task, then exits this print method. And after it exits the print method, then the next thread can enter into it. So next thread cannot enter into it until the first thread exits. So that is the concept of synchronization. So if you run it again, you can see all 5 numbers from one thread come first, then from another thread. So this is how we can change the scenario from non-synchronized method to synchronized method. So hope this makes you understand how we can make 2 threads use the same object, and what I mean by 2 threads entering into the same method at the same time. And also you need to understand it is only when 2 threads are using the same object. And if I'm using 2 different objects, it is not going to work. That means 2 objects can be accessed by 2 different threads. There is no synchronization in that context. Okay, so this is all about multiple threads trying to use one object and trying to enter into the methods of the object at the same time. And that's where you can apply synchronization to prevent second thread from entering into method as long as first thread is present. That's called synchronization. So when somebody talks about synchronization in Java, you know what they mean by this. Of course, it's by no means just confined to Java. This is a concept you see in every language that supports multi-threading.